Okay, the topic is OSI model. OSI stands for Open System Interconnection. It has been developed by the ISO. ISO stands for the International Organization of Standardization in the year of 1984. It is a seven-layer architecture with each layer having the specific functionality to perform. All these seven layers work collaboratively to transmit the data from one person to across to the globe. So what it means, whenever we are going to send the data from one end to the other end, they required a OSI model. It is a combination of seven different layers. All the layers have their own functionality, but they can work together. What it means, all the seven layers, they are using the different protocols, they have the different responsibilities, they have the different design issues, but they are working together to make a successful communication from one end to the other end. Okay, yeah, so this is the diagram of the OSI model. We have the seven different layers. Start from the downwards. The first one is the physical layer. Look at here in your screens. The physical layer is there. After that, the data link layer. Then the network layer is there. These all the three layers, they can also known as the hardware layers. These three layers. Then the fourth layer is there. The fourth layer is the transport layer. It is the heart of the OSI model, the fourth layer. Then we remain with the three different layers. Then the fifth one is the session layer. Then the sixth is the presentation layer, and the seventh is the application layer. And these all the three layers, they can also known as the software layers, or we can say the OSI model is a combination of seven layers, which we can categorize these layers into the three different categories. The first three layers, they act as a hardware layers. Fourth is the heart of the OSI model, and remaining three, they are act as the software layers. Okay. Now let's start with the first layer. The first is the physical layer. The lowest layer of the OSI reference model is the physical layer. It is responsible for the actual physical connection between the devices. So what will happen whenever the communication is trying to be done between the two different devices? First, we make a physical connection between these devices. And who is responsible for this physical connection? A physical layer. Physical layer is responsible for making the physical connection between the devices. The physical layer contains information in the form of bits. The data that can be traveled at the application layer, that can be traveled in the form of bits. And we all know we have the two different types of bits, zeros and one. And we have the combination of bits is 0 1s combination is there. So it is responsible for transmitting individual bits from the one node to the next. This layer is responsible for sending the data in the form of bits between the two different nodes, computers or system, you can say anything. When receiving data, this layer will get the signal received and convert it into zeros and ones and sends them to the data link layer. The upper layer is data link layer, or the second layer is data link layer, which will put the frame back together. So what will happen? We are dealing with the first layer. The name of the first layer is physical layer. The first thing is physical layer is responsible for making the physical connection between the two different nodes. First, the connection is made. After that, it can send the data in the form of bits. It receives the data and converts the data into the zeros ones combination. And zeros ones is known as the bits. It sends the data in the form of bits, and it sends the data to the upper layer. Upper layer means the second layer, and the second layer is data link layer. We are discussing it in the previous slide that it is a combination of seven layers, but all the seven layers, they work collaboratively. Now it receives the data, it converts the data into the bits, zeros ones combination as shown in the figure. Look at here. We have the three frames 1100, 1110, 0011, and then it sends that frame to the upper layer, and that upper layer is data link layer. Clear? Now, the functions of the physical layer are, what are the different functions can be performed by the physical layer are the four different functions. First, bit synchronization, to sync the bits into the particular order. The physical layer provides a synchronization of the bits by providing a clock. This clock controls both sender and receiver, thus providing synchronization at bit level. Now the clock is there. What is the functioning of the clock? Synchronization means to make a synchronization between the sender and the receiver. How it can be happened? It can be happened with the help of clock. Suppose I am a sender, you all are the receiver. I am sending some bits, you are receiving some bits. But how it is possible that I am sending the number of bits and you all are able to receive all the bits? This can be applicable with the help of clock. How it is possible? Suppose we have a clock. On every single second, I send a single bit. On every single second, you receive a single bit. What will happen? At the first second, I send the bit. At your first second, you receive the bit. Another second is coming, I sending another bit, and you receiving another bit. What will happen? After the end of 10 seconds, I am able to send the 10 different bits, and same with you, you are able to receive the 10 different bits. Clear? This is the first function of physical layer. Now the second, bit rate control. Bit rate means the rate of the bits, the sending rate is equal to the receiving rate. That can be possible if the synchronization is there. As we discussed earlier, we have a clock over there. For the first 10 seconds, I am sending the 10 bits, you are receiving the 10 bits. Automatically, the bit rate is controlled. The physical layer also defines the transmission rate. That is the number of bits sent per second. Now we can decide it with the help of clock. I am able to send the 1 bit per second. The bit rate is controlled. What will be happened? The total number of seconds is equal to the total number of bits. Suppose I have a 25 bits to send. The time required for sending these 25 bits is 25 seconds. This is called the bit rate control. Clear? The third, physical topologies. Physical layer specify the way in which the different devices, you can say the devices, the nodes, the systems, how they are arranged in a network. What it means? Physical connection is made at the physical layer. So how the physically they are connected with each other, that depends upon the topology, which topology we are going to arrange a different systems. The number of topologies are there. For example, the bus topology, the star topology, mesh topology, etc., etc. Clear? The fourth and the last is the transmission mode. Physical layer also defines the way in which the data flows between the two connected devices. The various transmission mode possibles are simplex, half duplex, full duplex. The fourth function of the physical layer is it can decide the transmission mode, the mode of transmission. We have the three different modes. Simplex, in which only the one-way communication is there. Suppose if we are on the simplex mode, only I am able to send the data, you only receives the data, but you are not able to send the data. This is called a simplex. Second, a half duplex. In half duplex, the bidirectional data is there, but not at the same time. At the same time, only data can be flow from the one side. What it means? Suppose we are in the half duplex mode. I am sending the data. At that time, you are receiving that data. When I'm complete with data, now you can send the data, and I am able to receive the data. The communication is bidirectional, but not at the same time. And the last one is full duplex. Full duplex means the bidirectional and sending as well as receiving simultaneously. You can able to send the data and receives the data at the same time. This can be happened in the case of full duplex. Clear? So these are the functions of the physical layer. This is all about the first layer. Now comes to the second layer, that is data link layer. The data link layer is responsible for the node to node delivery. Node to node, system to system delivery is responsible for. The main function of this layer is to make sure data transfer is error free from one node to another. What is the major responsibility of the second node is The data can be transferred from sender to receiver error-free mode. No error is there over the physical layer. Clear? When a packet arrives in a network, it is the responsibility of DLL to transmit it to the host. DLL is a short form of data link layer, and it can receive the frames as shown in the figure. Look at that. This is a one frame. The outer part is a frame, and that contains the three boxes. What it means, you can simply add the bits. The combination of bits is become the frame. This is all about the data link layer. The two functions are there. The first is data link layer is responsible for node to node delivery, system to system delivery. But the major responsibility is to make that data error free. Clear? Now, the functions of the data link layer. It has the three main functions. These three main functions. The first is framing. Framing is the function of the data link layer. It provides a way for a sender to transmit a sets of bits that are meaningfully to the receivers. This can be accomplished by attaching special bit pattern to the beginning and the end of the frame. What it means in the simple language, framing is a combination of bits. It can take the number of bits, make a combination of these bits, and it becomes the frame. But it can assign a new work over the frame as it can assign the start of the frame as well as the end of the frame, so that the receiver comes to know from where this frame is started and at which point this frame is end. Clear? This is the first function, framing. Second, the physical addressing. As we know, the major responsibility of this layer is system to system delivery, and system has a physical address. If the system to system delivery is there, they have the knowledge about the physical addresses of that systems. Clear? After creating the frames, whenever the frames are created, the data link layer adds physical address of the sender or the receiver in the header of the frame. Now it makes a frame, and this layer is responsible from system to system delivery. Suppose we are sending the data from system 1 to system 2. At the system 1, the frame is created. Whenever we are sending the data, first we add the physical address of system 2 in the header of the frame, because now whenever we add the physical address in the header of the frame, now that header, that frame automatically knows where it are going to be delivered with the help of that physical address. Clear? Third, the third is error control. It makes the data error free. Data link layer provides the mechanism of error control in which it detects and retransmits damaged or lost frames. What will happen? It have the number of mechanisms are there. From these mechanisms, they are able to know the damaged data or the lost data, that damaged and lost data due to the occurrence of the error. Whenever error is there, it simply realizes the error, and that error causes some damage to the data. It can simply replace that damage. What is the damage? Damage means the damage can be happened on the frames, and that frames is the combination of bits. So what will be happen? The bits can be removed, or bits can be lost, or the frames can be lost. So they can add the new bits, or they can add the new frames to that particular data. This is all about the second layer. The third functionality, the fourth functionality is the flow control. The data rate must be constant on both the side. Flow control, as we discussed in earlier, if we have the clock point is there, we can easily control the flow of data. How we can control the flow of data? Suppose I am sending the 1 bit per second, 1 bit per second, and you are receiving the 1 bit per 2 seconds. What will happen? After 10 seconds, I am able to send the 10 different bits. But after 10 seconds, you are only able to receive 5 bits. Where are the remaining 5 bits? They can be lost in the traveling way. So to control the flow of data, they required a flow control. With the help of flow control, they make a flow in a controllable position by assigning some values. So what will be happen? Now, if the flow of the control is remains the same, so my sending speed is 1 bit per second, it automatically change up your speed to the receiving speed is 1 bit per second. Now the control of the flow is equal. Now, after the end of the 10 seconds, I am able to send the 10 bits. And after the end of 10 seconds, you are able to receive the 10 bits. Clear? This is called the flow control. Now, the next is access control. Access control is when a single communication channel is shared by multiple devices. The MAC sublayer of data link layer helps to determine which device has control over the channel at a given time. What it means? Suppose access control is in the simple language. Suppose we have the number of we have a number of systems who want to send their data. We have the number of nodes over there, but the communication channel is single. So what will happen? Suppose we have the 5 systems who wants to send its data, and the communication link is single. What will be happen? Only one system is able to send the data at the same time. So it is the responsibility of the MAC sublayer of data link layer to give the access of that transmission media to a particular system. This is called access control. Clear? To whom it gives the access, the control of that access of the communication channel. Clear? Now, the third layer is there. The third layer is network layer. Network layer works for the transmission of data from one host to the other located in the different networks. It also take care of packet routing. Now, whenever first we receive the bits, we make the combination of bits at the second layer. It becomes the frames. Now, the combination of frames becomes a packet, and we all know the data is sent in the form of packets. Who is dealing with the packets? The network layer is dealing with the packets. Now, it also take care of the packet routing. They can decide the route of the packets. Selection of the shortest path to transmit the packet from the number of routes are available. The sender and the receiver's IP addresses are placed in the header by the network layer. As we discussed in the earlier slides, we simply add the physical address of the receiver onto the header. Now, suppose the physical address is system number 10. Now it knows that that packets can be received at the system number 10. But we have the multiple paths are there. But which path can be followed by these packets? That can be decided by the network layer. Network layer can decide the route. It can analyze all the routes. They have the number of mechanisms. They apply the different algorithms. After that, it picks a shortest route, time-saving route, and given to the particular packet. Now the packet can follow the particular route to receives at the receiver's side. Clear? The functions of the network layer are it has the first function is the routing, and we all know what is the routing. The network layer protocols determines which route is suitable from source to destination, which is the shortest route. Network layer picks that route, add it into the header of the packet, and sends the packet. The function of the network layer is known as routing. This function is known as routing to decide the different routes for the packets. Second, logical addressing. In order to identify each device on the inter network uniquely, network layer defines an addressing schemes. A new addressing scheme is defined by the network layer. The sender and the receiver's IP addresses. IP means Internet Protocol addresses, and that are unique for each and every system, are placed in the header by the network layer. Now, what will be happen? It can add the IP address of the system to the header of the packet. Now the system can find the IP address and receives at the destination point. Such an addressing distinguish each device uniquely and universally. And these IP addresses are the uniques. As the example, you have the different roll numbers, you have the different names, but the name should be remains the same. The two students can have the same name, but the university roll numbers, they are the unique ones. Same as the IP addresses are the unique ones. Suppose the two names are there. Suppose two students whose name is Amit and Amit. But the first Amit, he has a roll number is 001. A second Amit, he has a roll number of 002. What it means, it is a logical address. If I want to call to the or send a message to the second Amit, I can simply pick the message university roll number of that particular student. Clear? So these are the responsibilities or the functionalities of the network layer. Next, the transport layer. The fourth is the transport layer. It is the heart of the OSI model. Transport layer provides services to the application layer and takes the services from the network layer. The data in the transport layer is referred to as segments. Now, data becomes segments. In the first layer, data comes in the form of bits. In second layer, bits combination is called frame. In third layer, frame becomes a packet. In the fourth layer, now it referred as segments. It is responsible for the end-to-end delivery of complete message. Now, the main functionality of the transport layer is it is responsible for sending the complete message from where the messages start and from where the messages end. It is responsible for sending the complete message from one system to the other system. The transport layer also provides the acknowledgement of the successful data transmission and retransmits the data if an error is found, and it is responsible for the successful data delivery with the help of acknowledgements and retransmit the data if any error is there. Clear? So this is the responsibility of transport layer. Now the services provided by the transport layer. It provides the services, two different services. The first is connection oriented service and the second is connectionless service. We have the two different services. Okay, the first service is connection oriented. What it means? Connection oriented means the physical connection is over there. Connectionless, no connection is made. This is a major difference. It because the transport layer is responsible for the complete message delivery from one system to the other system. And whenever a message is sent from one system to the other system, we have the two options. Either we go for the wired media or we go for the wireless media. This is the same one. Connection oriented services, if the connection oriented services are there, what it means, first we make a connection between the two devices, a physical connection is made, then we send the data, then we terminate the connection. But in the connectionless services, no connection is there. We can directly send the message from the very first minute of the transmission. So this is all about the transport layer. The functions of the transport layers are, now the function of the transport layers are, the first is segmentation and reassembly. This layer accepts the message from the session layer, breaks the message into the smaller units. Each of the segments produced has a header associated with it. The transport layer at the destination station reassemble the message. What it means, it can receive the complete message, it can divide the message into the segments, but it can give the numbering, the reference number in the headers, sends all these segments to the next layer. The next layer receives all the messages, all the segments, and with the help of the reference number that is associated in the header, they can reassemble the complete message. Suppose I am trying to send the message towards you. The message is large in the volume, so I can divide into the 4 parts. But I give the reference number to the parts like part 1, part 2, part 3, part 4. Whenever you receive the messages, suppose you are receiving in the different order, the part 4 is received at the first point, then part 1, then part 3, then part 2. But with the help of reference number, you are able to arrange all the 4 parts in a similar order, like part 1, part 2, part 3, part 4. This is called segmentation and reassembly. And the second function is service point addressing. In order to deliver the message to correct process, transport layer header includes a type of address called server point address or the port address, as we discussed earlier. The messages, they are working on some processes. The processes, they are working on some ports. So we required a port number if I want to send the message. So these port addresses are known as the port address, or you can say the service point address. Thus, by specifying this address, transport layer makes sure that the message is delivered to the correct process. Or I just give you the simple example. Suppose you have two addresses. The first address is of your home address, For example, your home address is house number 123 Majita Road, Amritsar. This is your home address. The you can say the address or the IP address of your system. Now comparing this, IP address is similar to your home address, but we required a port address. Port address means suppose you are ordering something from Amazon. Here you can write your name. As suppose I order something, I write Amit Singh, then I write house number 123 Majita Road, Amritsar. What it means, the IP address is house number. The delivery boy comes to my home and asking for the where is Amit. Now the 5 person are living in my home, for example, but out of these 5, it can deliver that packet to me. Same in the case of your system has an IP address. First, this data is received at the IP addresses, but now after that they are looking for the port. On the particular port the process is running. Clear? So this is called the service point addressing, or you can say this is the concept of port addressing. This is all about the fourth layer. Now we move further for the fifth layer. The fifth layer is session layer. The layer is responsible for establishing a connection, maintenance of sessions, authentications, and also ensures security. This layer is basically the main responsibility is to make a session. Session is whenever suppose you are make a call to your friend. Suppose you are talking with your friend for 2 minutes. This is called a session. A 2 minute session is there. Same in the case of systems, they maintain a session whenever a data is whenever a network is connection is established, session is start. It can deliver the message. Whenever the delivery is completed, it can terminate the connection. Whenever the connection is terminated, the session is closed. Clear? This is called the session. The function of the session layers are session establishment, maintenance, and termination. This means first it can establish the session, it can maintain means it can take record of this session, and after that the terminate that particular session. Second, synchronization. This layer allows the processes to add checkpoints which are considered as the synchronization points into the data. These synchronization points helps to identify the error so that the data is resynchronized properly and ends to the messages are not cut permanently and the data loss is avoided. I just give you the example. Synchronization means they have the checkpoints. Suppose I am going to send you the 100 packets. I make a checkpoint after 10 packets. What will happen? Whenever a 10 packets are received, a checkpoint is automatically ticked. Whenever second checkpoint is ticked, I come to know 20 packets are received. If the third checkpoint is not ticked, what it means, there should be a problem from the 21 packet to the 30th packet. This is called the synchronization. And the last one is dialogue control. The session layer allows two systems to start communication with each other in half duplex or full duplex mode. Whenever a connection is established, they can communicate the data into the two mode. Half duplex where one can send, each other can receive. Only sending or receiving can be happen at the single time, not at the same time. But full duplex, sending and receiving at the both the times, same time. So this is all about the session layer. Now the next is presentation layer. The presentation layer is also called the translation layer. This data from the application layer is extracted here and manipulated as per the required format to the transmit over the network. What it means, they can collect the data is available at the presentation layer. Now the main functionality is to convert the data into the presented mode. Presented mode means now the data is presented in front of the users. Clear? The functionality of the presentation layers are, first is translation. Translation means ASCII to EBIC code, means translation is there. They can translate the data according to the user requirement. Second is encryption decryption. If any encryption is there, they can convert the data into the decrypted, if the decrypt the data and make it available in the plain text for the users. Third is compression. It reduces the number of bits that needs to be transmitted over the network. Whenever a large amount of data can be sent from one end to the other end, we require a compression. Whenever a compression is made, the size of the data becomes the small, and small data can be easily transferred from one end to the other end. So the basic functionality of the presentation layer is all the data can be received and now it can be converted according to the user need, because in this layer they are going to present the data that is received. They can present the data, and the three function: first is translation, they can translate the data. Second is encryption, decryption. If any encryption is there, they make decrypt that data and make the ciphertext into the plain text. And third is the compression. If it requires, they go for the compression. And now the last is the application layer. Sixth is the presentation layer. The data can be presented with the help of some applications. Or suppose you are receiving the emails, and which application you are using? The Gmail. This is the same as you are using the Gmail. By with the help of Gmail, you are receiving the mail, but that data is represented towards you in the format of mail, and that is the functionality of the presentation layer. But at the last layer, this is responsible for the number of applications. We have the number of applications in our cell phones. We have the number of applications in our laptops through which we can receive the data. You are receiving the data, or someone sends you the message. Number of methods are: you are receiving a text message, by which you are receiving the message application. You are receiving the WhatsApp message. At this, you are receiving the WhatsApp application. You are receiving the message on Messenger. Here, you are using the Messenger application. So this is all about the application layer. At the very top of the OSI model stack of the layers, we find the application layer, which is implemented by the network applications. These applications produce the data which has to be transferred over the network. This layer also serves as the windows for the application services to access the network and display the received information to the receiver. In the short form, you can say all the data that can be received by the transport layer, by the presentation layer, they can present the data with the help of number of applications. And these number of applications can be available at the topmost layer, and the seventh layer, that is called the application layer. The functions of the application layers are network virtual terminal. They can make the virtual terminal through which we can access the applications. The file transfer, access and management, the FTAM system through which we receive the file and we fetch the file. Third, the mail services, either the Gmail, the Yahoo Mail. And the last one is directory services, through which we are able to receive the directories. Directory means we are receiving some databases. So this is all about the application layer, and this is all about the OSI model.